Hello everyone, welcome to my YouTube channel. I am your Deepak Prasad studying at Sri Venkateswara College of Engineering. From today we are going to start with the second sem video assignments. So today's subject is mathematics. Subject code is BMITS 201. I study in DEU class sem 2. So the topic for today is applications of angles and projections in real life. We are going to discuss about 15 specific applications of angles and projections in real life. First application is in construction works. Construction works it is basically of two types: building construction and surveying land. Building constructions, angles and projections are crucial in determining the orientation of structures such as buildings and bridges to maximize sunlight exposure and energy efficiency. And in surveying land, surveyors use angles and projections to measure distances and map out of land features accurately. Architecture and civil engineering. These two are one of the main applications of angles and projections. In architecture, angles and projections are used extensively in designing buildings. Architects consider angles when planning structures to ensure stability, functionality, and aesthetic appeal. For example, roof angles are calculated to shed water efficiently and provide adequate ventilation and sunlight exposure for occupants. In civil engineers rely on angles and projections when designing infrastructure such as roads, bridges, and tunnels. They use projections to create accurate blueprints and plans, ensuring that the construction projects are structurally sound and comply with safety standards. Angles are crucial for determining slope alignments and elevations in road and railway design. The next applications are art and design and also navigation. In the field of arts and design, artists and designers utilize angles and projections to create perspective in their work. Understanding concepts like foreshortening and vanishing points helps artists accurately depict three-dimensional objects on a two-dimensional surface. Whether in painting, drawing, or sculpture, angles play a crucial role in creating depth and and realism. When we come to navigation, navigators use angles and projections to determine direction and distance during travel. Techniques such as celestial navigation involve calculating angles between celestial bodies and the horizon to determine a ship's position at sea. In modern navigation, tools like compasses and GPS devices rely on projections to provide accurate directions and coordinates. The next applications are photography and astronomy. In photography, photographers use angles and projections to compose visually compelling images. By adjusting the angle of view and controlling perspective, photographers can create dynamic compositions that draws the viewer's eyes. Understanding the principles of angles and view and perspective distortion allows photographers to capture scenes with depth and impact. Astronomy. In the field of astronomy, astronomers use regular measurements and projections to study celestial bodies and phenomena. They calculate angles to determine the position of stars, planets, and galaxies in the night sky. Projections are used to create maps of the sky, enabling astronomers to identify constellations, track celestial motion, and predict astronomical events. Sports analysis and geometry education. Sports analysis. Coaches and analysts use angles and projections to assess athletic performance and strategy in sports. Video analysis tools allow coaches to review footage from different angles to analyze player movements, techniques, and game dynamics. Understanding the angles helps coach optimize training methods and develop effective game strategies. Geometry education. In In geometry education, angles and projections are fundamental concepts taught in mathematical education. Students learn about different types of angles such as acute, obtuse, right angles, etc., and how to measure and calculate them using trigonometric functions. Projections are introduced as a way to represent three-dimensional objects on a two-dimensional plane, laying the groundwork for advanced geometric concepts. The next two applications are urban planning and mechanical engineering. Urban planners use angles and projections to design cities and urban spaces. They consider factors such as sun exposure, wind patterns, and traffic flow while determining the orientation and layout of building and streets. Projections are used to create zoning maps and urban plans to promote sustainable development and quality of life of residents. And in the field of mechanical engineering, mechanical engineers use angles and projections in designing machines, mechanisms, and mechanical systems. They calculate angles to determine the motion of forces acting on a mechanical component, ensuring that they function efficiently and safely also. Projections are used in technical drawings and CAD models to communicate design specifications and dimensions accurately. Weather forecasting and medical field. Coming to these fields, in weather forecasting, meteorologists use projections to represent weather patterns and predict atmospheric conditions. Weather maps and satellite images use different map projections to visualize temperature, precipitation, and atmospheric pressure across various regions. Understanding projections helps meteorologists interpret weather data and generate accurate forecasts and for public safety and planning purposes. In medical field, professionals use projections in diagnostic image techniques such as X-rays, CT scans, and MRI scans. These imaging modelites produce two-dimensional projections of three-dimensional structures within the body, allowing doctors to visualize internal organs, bones, and tissues. Understanding projection geometry helps radiologists interpret medical images and diagnose conditions accurately. The last two applications which we are going to see is computer graphics and video game development. Computer graphics, graphic designers and animators use angles and projections to create computer generated imagery, which is nothing but CGI, for films, video games, and virtual simulations. Techniques such as perspective projection and ray tracking are used to render three-dimensional scenes on a two-dimensional screen, creating realistic visual effects and immersive virtual environment. Next, in video game development, game developers use angles and projections to design virtual worlds and gameplay mechanics. Projections are used to create game environments, simulate lighting and shadows, and calculate collision detection for objects and characters. Understanding angles helps game designers create the dynamic camera angles and optimize player perspectives for an engaging gaming experience. So this is the use of angles and projections in the field of computer graphics and video development. So that's it for today. Thank you everyone. Hope you have liked this video. Please like the video as it carries marks. Thank you. Bye. Take care.